Hi. Now probably all can hear me clearly. And very good evening to everybody. So the name of the Google community, Google Plus community is Hadoop No Big Data, and you can join in there, and then we can have discussions. Okay, great, great. So welcome to the class. This class mostly will be about the discussions of the problems which we had yesterday, and my plan is to give more time to solve the problems, these these problems, instead of spending time on theory too much. So I got solutions from some of the people. I got solution from Suksavat and a few more. And yeah, so some of us have actually worked on the problems which I gave in the last session. Okay. Okay. So I start the class with a very simple thing. Uh, okay. Let me hide the format. Okay. Great. Great. So today's class is again regarding the MapReduce. It is more or less about those 4 or 5 problems which I gave it yesterday. Okay. So today is a discussion about those problems because MapReduce is more about problem solving, a big data problem solving, than about any syntax or any construct. Okay. So there is a basic construct. How do we utilize it? How do we start thinking in terms of big data? Big data, when I mean, you will understand what do I mean by thinking in terms of big data is when you stop using lookups. Okay. Okay. So right now, all of you, whenever you are presented with a problem, you start making lookups, start doing iterations, and that is not a very efficient way of handling it in the big data side. So let's just go ahead. Okay. So in today's class, we'll be going through advanced MapReduce and a bit on testing. So first part, I'll go through something called streaming job, and then we discuss about all 4 problems. Okay. So is why I'm discussing it uh, in terms of streaming job, because you can then think in terms of your own construct and use that streaming job. Okay. So let me just so a streaming job is a Hadoop library which makes it possible to use any binary as mapper and reducer. Okay. So the command syntax is like this. We say we say Hadoop, and this is our library Hadoop jar, and is followed by a space and then streaming. So so Hadoop streaming is just another library in Java which makes it possible to execute any command as mapper and any command as reducer. Okay, so this is the syntax of executing Hadoop streaming, and then you provide input, the file, the folder basically, where are you going to read the data from, and then you provide the output, this directory. Okay, so the data will be going to be written here. If this folder already exists, it gives an error. Okay, now in case of mapper, we provided a command yesterday. Okay, so what is mapper doing here is substituting. As for substituting, sed is a command which is called, I don't know, ed is for editing, and s for stream editing. This is a Unix command which basically is equivalent to control F and find space and then replace it with a new line. Okay, that's what this guy is doing. Okay, so while we uh, I mean using MapReduce, we are telling that this is my mapper. No, strings means stream editor actually. Okay, okay. Let me have a look. Yeah, stream editor. See, it's called stream editor. Okay. Yeah. So we here, instead of writing any code, all we have done is handed over a command which replaces the space with a new line. This is the command in the Unix which does this job. The the important aspect of this command is anything given as input streamed to it will be operated upon. So SED will take anything which is presented to as a standard input, as if a user is typing to it, and it will replace that space in it with a new line character. Okay, so it's equivalent to saying Control F. Whatever content will be provided to SED, it will replace space with a new line. And similarly, we have defined another command. Instead of writing code, we are just utilizing what is there in the Unix. Okay. We are just passing a command called unique and the argument is -c. So we are passing command along with the argument which we want to apply. So what unique c does is anything you provide as an input to unique -c, it will count the frequencies. Should I show you this once? So let's take the case of this one. So can you see my command line? Let me just increase the font. Can you see the command line now? So if I say echo hello, it just gives me it on the screen. And if I say this, this gives me back. Now if I pass it to another program called SED and say substitute space with a new line. Okay. And here there is, because it's Mac, so you need to provide one more argument here. Let's say I say press enter and then say okay. Okay, so all it did was it replaced the space with the new line character. That's what I did. Okay, so this is what, and if I say uh, here after this, if I say unique -c, it is going to just display the frequency of each words. Remember, the unique requires the data to be sorted. Okay, for example, if I say hello you and then say this, still if you see the frequency of 1 is 1 all across. Okay, and that is why you need to always sort it. Now see this. So basically this is what is actually going to happen. This is how we are going to compute the just a second. Understood. Input output mapper reducer, but what is the jar? Is it ready-made jar code? Yeah, so basically see the way Hadoop has been actually written is with the assumption, sorry, MapReduce has been written with the assumption that people will be writing code in Java. Okay, so when we say Hadoop jar, this is how a MapReduce logic was supposed to get executed. But one guy came along and he said, "My MapReduce logic is that that execute, I will execute the external commands. Okay, I will execute the external command, and that's what it is. So, a streaming job is actually internally a MapReduce in Java, which is basically calling these commands which you are providing instead of its own logic. Hope I make it clear." Okay, so this is what it is going to do. So inbuilt is your what? So I did not get your question. Okay. So what's your name? I mean, the one with the name developer is, are you Shashank? No, you must be Bhagwat, I think. Okay. Okay. So let me go through the commands. Is this inbuilt? Yeah. So Hadoop provides this command inbuilt whereby you create your code in Java and then you create your MapReduce code in Java. Then you hand it over to Hadoop. Okay. Now somebody some guy came along and said my MapReduce is nothing but is executing other binaries. Okay, and that's all. So this is not a inbuilt library, but nowadays it is being shipped with Hadoop. Okay, nowadays it is being shipped with Hadoop streaming. So this is what it is going to do. This sort, if you see, is the job which is being played by the Hadoop here. Okay, now let's get back to the screen. So here, if you see, what am I doing is basically defining my input folder. This is where all my files are stored. Okay, or if you have multiple files, you can comma separate them and put it here. Okay, and then you have output folder, then you have mapper, and then you have reducer. Now look at it, what is actually going on. For each of the chunk on the node, SED is going to get called. SED is your mapper. Okay, SED converted this to this by replacing space by the new line, and now Hadoop is going to reshuffle this, sort it, and reshuffle it. Okay, and pass it to unique everywhere. Okay, pass it to unique everywhere. So it will spawn, say for example, if it is making three chunks, then it will spawn three unique commands, three unique minus C, and then we'll give the result, and you'll get this result back. Okay, and these unique minus C are going to get executed on all machines. So the important aspect here is that when you are specifying your path locations like this should exist on all the task nodes or data nodes. Okay, these should exist on all the data nodes. Right. Here I'm using the data node and the task node interchangeably. Yeah. So the jar is uh, when we say jar, it's a syntax from Hadoop side. Hadoop followed by jar means I'm trying to execute a jar file. Jar is like a package of all of your code along with your library and XML file and manifest everything in one jar. Okay. So anything you provide to Hadoop should be in the jar format. So you could call any application that you may have. Yes, yes, yes. You can call any application you may have written, whether it in Shell, whether it in Python, whether it in Perl, or whether in PHP. And that is the reason I'm discussing this aspect. Okay. So whenever you are basically handing over your code or URL, you always make sure that it exists everywhere. Okay. It exists everywhere. Or you can put it in HDFS and then specify that this is where it exists in my HDFS. Okay. So you push any file onto an HDFS, including your all Python code, and then tell this command line command to consider pick the URL from the HDFS. Yeah, but the problem is that if Hadoop node task nodes are on different OSs, then it would not work. Although that is why, although I mean I have not seen anybody using Windows for that matter. I've always seen people using Linux for MapReduce. I'm not sure what will happen, but in past what I have seen is in case I'm using a command which does not get executed on all nodes, those nodes start giving error to me. For example, I was using a particular Python library which was not upgraded on all the nodes. And that's when we realized that, oh, there is a big problem. There is a library mismatch everywhere. And that so it became very difficult because some of the jobs started failing. So right. No, jar, even if there might be discrepancy between what jar is existing on various machine, right? So the ideal way or to do all of this is create your own jar, put everything into every other jar into that, push it to HDFS, and then ask Hadoop to execute that jar. Okay. Or if you're executing Python code, you push your all files onto HDFS and then let it execute. But Python is going to use the library which is installed on that machine, and that is what is going to give the problem. So there is always an incompatibility problems across the nodes. Okay. So that's what is the role of system admins to make sure that it works well. So there is one person who hasn't come. I think Vivek could not come today. I think Vivek could not come. Okay. Now let's see. So till the here, is it clear to everybody? In production system with a lot of node, it may be a problem to make sure all the nodes are updated simultaneously. Yep. Yep. So that is why I mean there is a strict policies to take care of all the task nodes, and you need to always make sure that your all nodes have same version of Java, all nodes have same version of Python, and in case you're using Python and having certain modules, then you will have to install the same modules all across, or you ship it along with your Python code. Exactly. So Kalyan, you are right. So once you package your program in jar, and once you include it, this jar will move across the cluster. Yes. So uh, uh, every node will create its copy from there during the lifespan of the task, and then it will execute. Yeah. So every data node will execute it, and then uh, make a copy of it. Actually, you can see that in case of running Uzi. No. Okay, sorry, Chintamani. I think I gave a wrong impression. No. So, in case you are not from Java background, that is why I'm displaying this here. Okay. All you have to remember is pass after this is you keep it as is. Okay, this line Hadoop jar and your streaming library jar. This is not something you have coded. It has come with Hadoop. When you install Hadoop, if you look into share folder and go into tool lib, you will find this library. Okay, and you pass this along to jar, and then you start writing whatever code you have written, you pass it as mapper. This one. Okay, like this. Okay. Or moreover, this is just an example, right? You can think in terms of ODBC jar, but it is just a library provided by Hadoop. Basically, its job is to execute commands for you. So one way you can, one more thing, you will not have to do it much. All you have to do to later on in the production environment is use a platform like Uzi. Okay, and Uzi will do a lot of jobs for you. Okay, Uzi will do a lot of jobs for you. All right, it will execute this streaming job and everything. If you remember, we showed it yesterday. There was an option of creating a streaming job there. So let me just take an example here. So this is my input directory. This is my output directory, and this is my mapper, and this is my reducer. Okay. Also, guys, basically, this cluster which we have created looks very inefficient. So I was trying to debug it today and was trying to fix problems with it. But it seems that this Cloudera Manager one requires a minimum of, say, a lot of RAM. Okay, and those kind of RAM is not available in the cluster machines. So I'm planning to install a vanilla separate. I'll provide two machines. One is just for the this demonstration of Cloudera Manager, and other cluster will be for basically providing the Hadoop MapReduce. Okay, so I will inform all of it. So this jar is within HDFS or Linux file system. It is in the Linux file system. Yeah. So your question, Anto's question is, do we need to instruct Hadoop each and every time? Yep. So, but the thing is, once you create your job description in the Uzi, then you don't have to create these things. You just create your jobs, define all of it there, and let it be there. Okay. Yeah. So Gaurav, you're right. If you're not using Java directly for MapReduce, in that case, you will require. Why do you have the output? Good question. So basically, because this is batch process, right? Any output, it is not going to display on the screen, right? It has to save somewhere, right? It reads the data from somewhere, process it, and saves it back somewhere. That's the job. Okay. So I want to give you a little demo. Let me just first show you. So I'm logged in onto something called hadoop3.nobigdata.com here. I'll just increase the font. Can you see? Good. Oh my god. Oh my god. Is it too big? Okay. Right. Good. This is good enough, I think. Now let me just show you. So this is my a server called Hadoop 3, which I recently purchased because Hadoop 1 and Hadoop 2 looks very bad. And so let me have a look at what is there on my Hadoop fs minus L, and I say root. This is a different directory structure from yesterday. Okay, word count, and then I say input. word counts. This is called, okay, users root. Users root word count. So there is a big file called big.txt here. Okay, some ignore this first error. Okay, so here you see this user slash root and this. It is a very big text file basically. Okay, and we are trying to read this folder, this basically anything that is lying there, and then we are trying to count the frequencies of the words in that file. Okay, and for that we are going to execute this command. I'll reformat it because there are strange question mark characters. There are these. Okay, and here we go. Okay, now fine. So I'm taking this and doing this. Now it should give an error because that output folder already exists. Okay, it says output folder already exists. So I'll just say output 5 here. And now it is going to run all of it. It has created a MapReduce job. Now it's running that job. And the URL to track this job is also provided here. Here, if you see this one, you can go into my browser and access it. I hope it works. So map is in progress, is done. Reduce is in progress. So I think it is done, so it's dead. And for whatever reason, I can't see it. Now it is done. It shows you all of these records saying number of bytes read, number of bytes written, read operation, large read, and then total time spent by all map tasks, reduce tasks, and then all map input records, output bytes, everything you have. Input groups are these many, reduce shuffle these many bytes, and shuffled maps are total 2. Merged map output, okay, and it has stored the data where whatever we provided the output directory, it has stored that data there. Let's have a look at what is there. Okay, there is a part folder, part 00. Okay, and if we say this, then there you can see we can do one thing that we can do a cat on this file and then save it locally. Whatever output comes, it will be Hugh's file. Wait a second, what happened? Okay, it's not that Hugh's. Okay, since we have not removed all of these special characters, we are seeing all of this. And note that it will not be sorted by frequency, it is sorted by the word which is there. And since it has punctuation marks, it has all double quote, single quote, exclamation, everything. That is why these words are getting considered differently. You see this? So if you do a cat out and then say sort minus nr and then say this. So the is most common, then off, then space is that I think that is some other character tab probably, and all of these. Okay. So these are the top most frequent letters in most frequent words out of this. Okay, the, of, and, to, a, and, in, and so on. Okay. So if you had to do this, you might have to, if you had to sort it by the frequency, you might have to again create another map which will have the frequency on the key and the value as the word. So it will happen in two passes. Okay, that we'll discuss very soon. So till here, let me have the question. Okay, right. So, Anto's question is, can you cat the directory? No, because that exists in that network file system HDFS. Until you install, until you install a Fuse FS, okay, which basically help you mounting any HDFS just like another directory onto your machine, you will not be able to use a simple cat. Okay, the bridge between you and HDFS, because this file is stored completely different way. Okay, so you will have to, the formats are different in so HDFS is basically not really a local native format. It's basically a representation of lots of file system in one. Okay, so the file format, the format, I mean, it's a little difficult. Okay, basically it's a different file format altogether. Okay, so Unique decided to return the result in the way we say the data. No, I did not get. I did not get. The results came out frequency word. Yeah. So results are like this. If you see the frequency and then followed by a word. Okay. Frequency and then followed by a word. So this is how unique gives the result. Unique minus C. Yeah. This is unique. If you say echo, let's say, how should I say? Let's say I'm doing head and say big.txt. Okay. And anything you do, right? Echo, hi, how are you? Okay. Let's say string. And then when you pass it to unique minus C, it shows you this. So that's a way it gives. Okay, great. So I'm hoping that this streaming job is good enough for you. Okay. In case you are a Java programmer, you can create, I will also explain it, but though I will not be able to demonstrate it today. Basically, you will have to create your jar and then you write your code in terms of MapReduces. If you are not a Java programmer, you use this command and then pass on your program name. Okay. After putting your program name onto HDFS or exclusively installing on every machine, you can do that. Okay. But installing it on every machine, it's a stupid idea. So you stick to this. Okay. You should just hand it over. So this is what this guy has done for you. First, it executed SED for each chunk of file. Then it executed unique minus C after sorting and reshuffling the data. And you got this. Okay. So I have given the demonstration. Now, example not seen clearly. This one, this one. Can you see this? Shashank, is it clear to you now? If you have questions related to this, okay, don't worry about taking a note of it. I will anyway share the PDF with you guys, so do not worry about it. Okay. 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 So, Shashank, do you want me to give a demonstration again? So, Bhagwat's question is again, why sorting by Hadoop is better than the regular Unix? Because in regular, if you have to do on multiple machines, then regular Unix job will kill you, right? Remember yesterday we did a external sort using Unix, and we handed over our jobs to lots of machines. Okay. So there are a couple of more jars in with that come with Hadoop. One is your simple examples jar, which has all the examples in it, and then you have, you have things like testing jar, and one is client jar that comes in, which you include while you're programming your client. Okay, while you're programming your this. Okay, okay. I think I'm not getting what you guys are trying to say. Please include the previous line. On a single machine, HDFS, on a single machine HDFS, how? No, 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 it is not. On a single machine, using Hadoop is stupidity. It's as simple as that. Now your question makes sense. So Hadoop sorting does not make any sense if you have a single machine. Okay. So was I able to answer Bhagwat's question? Okay, I'm missing other people's question. So Anto's question was there. Okay, okay. So Shashank, are you able to see? I could not get your question. So should I demonstrate you the command again? Okay. Shashank, I will show you the command again. Bhagwat, if we all start speaking, right, then we are 11 people, right? And it'll become very difficult. Okay. So same command, whatever is there, I have pasted it here. It won't be too visible to you. Okay. So if you had installed Cloudera by default, you can execute this command what I have sent. What is there in the presentation? Okay. So I've just submitted the job again, but this time I've changed the folder to something else, and now it's doing a MR job. Okay. And it will save the output in the HDFS. And so it is saying output directory is this. Okay. Now what you can do is you can say Hadoop fs minus cat, and then you can say this. Okay, is a directory. So you say part, and then so there is a it creates a lot of part files. Okay, it is little too much of data. So it is giving out all of those results. Okay, and if you see sir is written so many ways, exclamation question and then double quote and all of this. If we do a little bit cleaner, if we deal it a little cleanly, then we can come up with the better ways. Okay, if we remove the punctuation marks and then we can get a better frequency. Okay, so hope I was able to uh, demonstrate you. So all I did was executed my command and then did a cat, Hadoop fs cat. Okay, the files are stored in a uh, under that folder. It automatically creates part 0, part 1, and that sort of files, and then you can do the cat. Great. Good, good. Okay, now what we did here made sure that HDFS broke the data to different machines. Yes, my questions are related to the same topic. On a single machine, HDFS, how is efficiency better than Unix approach? It does is not if your HDFS is on multiple machines. So your question is, if my HDFS is on multiple machines, okay, and we are using a single Unix host, and then we are using Hadoop. Yeah, because then in that case you don't have much of an alternative. Okay, but in case you have HDFS mounted on your local machine, or you are using HDFS command, okay, you have a single machine on which you are executing everything. It is just that you have got HDFS access. Okay, so Bhagwat's question is, why is Hadoop better than Unix? No, I'm not getting your question. So, see, before Hadoop, everybody was coding their way, coding their logic and distributing it. Okay, okay. So they could have done a better job. But it is too much of a engineering. If one machine goes down, you have to hand over the same code to another machine and let the machine do the job. Okay, okay. So you are not ensuring that there is a distribution. You are letting Hadoop do it. So whatever input directory you gave, okay, Hadoop is going to find out what all files are there for you. Okay, in that directory. In this directory, Hadoop is going to find out what all files are there. Then it is going to find out where all the chunk of these files are stored on the data nodes. Okay, yeah. The job will be done at many nodes, but right now I have just one single node, Hadoop 3. In case I have added more nodes to this cluster, then it would be executing on multiple nodes. So if you see, it is when you there is no guarantee from your Hadoop side. It all depends on the dynamics, okay, of the HDFS. So the more nodes you have, it will keep on redistributing, and you can see that from the management interface of cloud this Hadoop. It will keep on it will keep on dividing your file if it is going beyond 64 MB. Okay, and even at the smaller size, it keeps on dividing. So it does a lot of logic in there. Okay, right. So performance is not directly proportional to splits, because if you have a million splits, if you have a million computers, and all you are trying to do is concatenate, find the frequency in 1 MB file. Okay, so it will become really, really bad. Then the performance will really, really bad. So it does a lot of balancing for you. Does the computation that how much replication do you want, how many nodes are there, how many nodes are going bad, all of this keeps on going, and on that basis it divides the data on various nodes. Now Hari's question is, if we want to sort in different order, what do we do? Okay, In that case, you will write another set of map reduce jobs, okay, to do the sorting for you. Okay, because here sorting was required in order to ensure in order to group them to group the word together and find the frequencies. So of course the sorting right now would be on the keyword, on the word, instead of the frequency. In case you want to sort on the frequency, then you'll have to write another map job which will swap the key to value, and the output will be sorted by the frequency. No. Here it's like standard Unix command way, where your input data is in plain text. Okay. And you have the by default in the streaming job, by default the tab separates the key and value. Okay. Tab separates the key and value, and before the tab is everything is considered as key, and you sort and Hadoop sorts on that basis. Okay. Sorting is lost once the command is finished. I mean, the file is maintaining the sorting. Yeah, but there is a difference. It's not a database. It's a batch processing system. Okay, so both have its own use cases. And yeah, now let's. Yep, yep. So anybody else is having questions? These are very interesting questions. Thank you, Bhagwat. And yeah, so hope everybody is understanding what uh, Chintamani and Bhagwat and Hari and everybody is talking. So everybody, hope everybody is on the same page. So should I move on? So yeah, Hadoop is like distributed OS. Okay, that's how you can look at it. So for streaming, field separator by default is tab. You can change the field separator by providing a argument there. Okay, probably minus f, I think. Okay, so all good. Should we move on? So, I mean, why I'm emphasizing on streaming job is because first, I don't have to compile or anything. This is the quickest way to get my work done. Second, there are in the whole class, everybody is from a different background. Only few people are from Java background. Okay. And this is a good way. The whole recommender system which I wrote for InMobi was done in Python. Okay. Later on, when people were converting it into Java, it took forever. And but the Python one just worked very nicely. Okay. And that was my first job in Python, and half of my life I have coded in Java. Okay, great. So I'm moving on. So this diagram is clear to everybody, right? So this dashed portion of this line shows the magic being done by Hadoop in shuffling, and then yeah. Now let's come to the problems. Mm, Actually, I prefer Python for my scripting job when I have to get my job done very quickly. But for building a larger product, okay, where multiple people are working together, I prefer Java. Okay, but then the discussion will go on forever. Okay, so let's talk about the question. So question is, if you have a large corpus of few terabytes, okay, a large corpus of few terabyte, and you have to do a frequency analysis. Frequency analysis means that what is the frequency of each letter in this corpus. Okay. And the frequency analysis is heavily used in determining the age of a text. So in every age or in every geography, the frequency of a letter is different. Frequency of letters is different. Similarly, while identifying the language and predicting quickly the language, frequency of letters is one nice criteria. Okay. So you have to do the frequency of letters and of a large corpus. How do you do it? Let me have the solutions of you guys. You must have thought about it. So Bhagwat is saying that since number of bins are limited, 26 bins, right? So we can probably make an array and keep on adding the value there. Now think in terms of the total, the text over the internet is around 100 terabyte. Okay. Now, do you think that Hadoop can be of use here, or say 10 terabytes? If you copy 10 terabyte of movies, how many days do you think it takes from one drive to another drive? It takes close to 10 days from one USB to another, just to copy 10 terabyte of movies. Okay. So Gaurav is suggesting a solution. He's saying that map will emit each letter and then one. Okay. Reduce will do a sum of values to calculate the frequencies. Okay. Okay. Yeah, drop that code. I'll like look at that code. And yeah, please, because I'm going to give it enough time, say 5 minutes for each problem easily, 5 to 10 minutes or more, because the whole session is about these problems only. Okay. And I'm going to leave it up to you guys to actually code it. Okay. I mean, whether you are writing in Shell or whether you are writing in Python, PHP, or any language of your choice. If you still like your C code, right, you can do that. All you have to do is read from standard input and write to standard output. That's it. In case of mapper as well as reducer. So compile your code, build a binary, and then put it to Hadoop and give at somewhere everywhere at the node or in HDFS, and then let it execute. Yep. So everybody is on that page here. So how do you need map and reduce if you have frequency of letters? And if you are supposed to do, so say first approach is this. Without MR approach, a simple program as suggested by Gaurav and Bhagwat, the simple is that create an integer array of 26 size and scan the text character by character. Increase the A0 for A and A25 for Z. I mean A25 as in capital A25 for Z, and all others in between. For B, it will be A1 and all. So every time you encounter a character, just increase a value at that particular location in this array. Okay. Okay. So as I explained that this may be inefficient if your data is too huge. Okay. So the problem with this approach is this does not have a RAM as the bottleneck, but the CPU and the network or disk IO are going to become the bottleneck because we are churning the text of half of the world. And in case you are really interested to churn a lot of data, if you look at the Amazon's corpus of web, it's around for 514 terabyte. Okay, you can use that corpus to do a lot of interesting churning of data. Right? Make sense to you? Basically, we were doing frequency analysis, basically finding frequencies of letters in a text. Okay. And also these letters are all converted into lowercase. Okay. So that the uppercase and lowercase you do not need to maintain that. Shashank Chintamani and Anto, Kalyan, Sukhsawat. I saw the Sukhsawat's way of handling it. It was nice. Basically, this is the way it was. Arun, yeah. So Gaurav was suggesting an approach. I missed that part. Gaurav was saying in Hadoop approach, there is an overhead. We need to load the data first in HDFS. So let's assume that the data is in HDFS. Okay, okay, right, right. So this is, yeah. So this is analogous to the same approach what I have just outlined above. Instead of using a dictionary, I've just used an array, and I initialize whole array of 26 size. Okay. No, I mean, no, it's not that. Yeah, this is just pseudocode. So basically, what you do is you make a note of, you create, you keep 26 numbers. Okay, one for dedicated for each character. The moment you encounter A, you increase the one variable called A. And the moment you encounter B, you increase the B, and so on. You keep on counting all these characters. Okay, or you have 26 fingers, you keep on counting all those. Okay, this is the one approach. Now the next approach is you wrote this code to count the frequencies. Basically, you can use the same code what you wrote in the previous approach as the mapper, and in the reducer you can sum up all the 26 keys, or basically you sum up all the values. So every mapper is going to output, this one is going to give you an output like what is the frequency of A, what is the frequency of B, and what is the frequency of C, on and so on. Similarly, all of the mappers are going to give you that output, and you do the reducer onto those nodes. Okay. And in the reducer, all you do is sum up everything together. That's it. So now you, at the end of it, you will get the, yeah, you will get the summation. Okay. Should I just explain again? So each one, each of your mapper is giving this output. Okay. Each of the mapper is giving me this output. So this is the character frequency. Let's imagine. Okay, this is the character frequency given by each is similarly. Let's say you have 100 such mappers. Okay, so first mapper gave this result. So each one gave this result. Similarly, it has got some other number here. Okay. So similarly, there will be this is my mapper number one, and this is my mapper number two. Mapper as in on each node, I ran a code which took the text and printed all 26 numbers. Okay. All 26 numbers. It counted the characters and then spit it out that hey, I encountered A these many times, B these many times, C these many times, and all. And this is happening on all the machines. And your reducer, what it will do is when this since it has a key as a, so all these numbers will be presented to the reducer one by one. So all reducer has to sum up 23 and 12. Okay, and the output will some way look like this. Output will basically reducer will be presented with the numbers like this. Do not worry, looking little scrambled. So output is going to be presented like this, and for B, and again for B it will be 122 and so on. Okay, I'll just remove everything else. For A and B, this is how it is going to look like. Okay, so it will combine all of A's together, Hadoop for you. Okay, because A is the key, and similarly it is going to combine this part for you, B, and will be presented to the reducer. Okay, reducer is going to take the key and the value and then sum the value here. This is the role of your reducer. You will have to write this code. Okay, so your reducer will get each line of this file. Each line as in key and array of values. Key and array of values. And reducer, all you have to do is sum up these numbers. Okay, okay. So I, this should be fairly simple. Reducer's job is this is what is going to be presented to the reducer, and then reducer will sum it. Okay. If we do unique minus C on the reduce, it won't make any sense. It will just give the counts. It will just give equal counts of task nodes actually. Okay. Okay. So from the source file abc.txt, how it will divide in order to avoid duplicate work. See, so what will happen? Say you have got a very huge file, okay, and you said, "Oh, I want to find the frequency of these all the files in this folder." You told this to Hadoop. Now, what is Hadoop going to do is create, find out on what all machines this file is existing, the portion of these files are existing, and those many mappers will be created, and each mapper will be doing that. So, is that what you're looking for? So basically it will avoid the duplicate work. There will not be any duplicate work as is, because mapper is going to run only on a small chunk on a separate machine. So Bhagwat is not clear on the map. Okay, okay, I can explain again. This is the time when the things should get clear. Yeah. So, can you explain the question? I'll try to explain it. I will show you my command. This one. So mapper, what it is doing is it is basically going character by character, and then splitting it. Do you mean if the size terabyte or petabyte MapReduce processes distributed to run on HDFS distributed environment? Yep, yep. This because if it is below 1 GB, right, you can do it yourself, or even 100 till 100 GB, your single machine will suffice in this case because RAM is not an issue, network is. No, SED will not do that. You'll have to use some other technique to go through character by character. In case of Python, I can do it very nicely and quickly probably. So I'm hoping Python is installed on this machine, and say I have a line. Okay, and this is my some line. I can basically go and say my line length is for I in line. I think do for line in I and print I. See, it's pretty straightforward. And you can convert the number basically if you have this, you can say minus a, and then basically you can say ASCII value. I forgot how do you do ASCII value. Okay. Anyway, you can do that the whatever way you want to do. Okay. And this is going to be left to you guys. Okay. So using Python, you can do that. Yeah. So it says the previous one. Previous is in this approach. Okay. This is the approach I was talking about. So you created a simple local program and you just asked Mapper to do the job for you. No, no, no. Okay. Oh, that is the reason you were confused all the way. Okay, 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 okay. Great. Now the anagram one. Okay. Kalyan, do not worry about that. Okay. I will try my best to explain it. And in case, I mean, I would say that do not worry that you do not know the programming. Okay. I'm trying my best. I would say you start with Python. If you want to learn now, I would say you start with Python because not because it's a great language or anything, but because it is quick to get started. It is there on every machine, and also there are lot of beginner kind of tutorial available. Okay. Yeah. So I'm going to stick to a pseudocode. There here I'm actually using pseudocode all the while. Okay. And it's very difficult to stick to a language because everybody has a different background. But you have a point. You have a point. So I'm trying to stick to general purpose libraries or general purpose things. Like, for example, the frequency counting, we did not even have to write a single line of code. Okay. So, but I make sure I'll make sure that you understand what I'm trying to explain. In case you get lost and I'm not explaining correctly, just buzz me and I'll explain it correctly. Because if I'm not explaining correctly, whether it's somebody is programmer or non-programmer, it will not be able to. It will not make any sense to either of the person. Okay, okay. Let's yeah. So here basically what I'm trying to do is I'm trying to the way we had been thinking all the while about our problems, that we have a dictionary, we have lookup methods available, and they do a job for you. How do you convert any of your text to any of your logic into MapReduce? Now let us look at this particular example. Okay, okay. So an anagram is basically a word which can be formed by twisting the letters. So what we are trying to do is, in a big corpus of text, we are trying to find out what are the anagrams available. Okay. Now, what are your suggestions? I got Sukhsawat's suggestion. Okay, but still, your suggestion was to basically. Should I open that? Yeah. So here, his suggestion was to find A or C or T in a word and then assign a value 1 for each character. If found A or C in a word and sum the value, then sorting word value will be 3 and check with dictionary. The problem is check with the dictionary, and second is that the word could be more than 3 letters. Okay. Checking with the dictionary is a difficult thing because uh, because the whole objective of using, okay, just a second. Okay, whole objective of using this MapReduce is to avoid dictionary. So if you have a corpus of few hundred gigabytes, then you cannot use a dictionary for this. Okay, and if you're going to do a disk lookup for each word against words, it is going to be really costly. So how do you break it into MapReduce logic? That is the question. But really, I mean, it's a good approach to begin with. So now somebody is saying, okay, okay. So Gaurav is saying, in the map, you you emit convert each word in lexicon order of letters. Okay, okay. So you are saying that sort the letters of the words, right? Is that what you're saying? No, I give me an example. Give me an example. What are you trying to do? Okay, okay, I got it. I got it. So basically, what he is saying that for each of the words, for each of the words, Do this. Good, 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 good. Okay, okay. For each of the words, key and words. Okay. Let me have a look. These are very interesting ideas. So, okay, okay. And so on. Perfect, perfect. Reduce, reduce key and words. Each output phase is a set of perfect, perfect. To convert easily, you can use ASCII value, yes. And Bhagavad, sum of the value for the key. Okay. Okay. Let me see Chintamani's question. Pick up word by word. Pick up the characters in each word. Check these exact characters in rest of the words one by one. Exactly. So your third point till first and two is good, but the third point, how do you check these exact characters in rest of the words one by one? How do you do that? If you do in the rest of the characters, rest of the words one by one, then it is going to take a forever. Think of the words as 1 billion words. Okay, and say you took the and you ordered this into letters eht. Okay, and okay, okay. Sort the words by ASCII. Sort the words. Do you mean to sort the letters by ASCII, or how do you want to do? And then find out the similar words, then count. Okay, okay. Hari is saying sort by and create a hash code. Okay, good, 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 good. So let me give a demo. Okay, I'll give a more 5 more minutes. Organize your thoughts, think about it. This is an interesting problem. So the idea is most of the lookup problems when we want to look up from here to there can be converted into sorting and join problem by merging the data together and then ordering them so that they come together. When you have to look something up in another dictionary, that means what you can do is you take the dictionary and merge it with your main data by the same key which you are looking for, and then those values which you are looking for will come together for the same key. So that is the whole idea. Okay. Text into array of words. Take the words into array of characters. Sort the array of characters. Find counts any words with yeah. So in the reduce, you do the count if the more than one words. Great. So should I give some more time? Just 1 more minute. Okay. Okay. I'm getting a great ideas from all the people. Suksavat, are you there? Did you? Okay. Okay. So basically, the way you have described, you have said that you look up the word. Can we avoid that lookup? Okay. I'm talking to Suksavat. So you can avoid that lookup by merging the dictionary into itself Okay. Okay. Great. So I'll give you this you diagram which you can see. Good, 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 good. Let me show you this next screen. So here is your main string. Okay. The cat act in tic-tac-toe. Okay. And then that string is given to mapper. Okay. What mapper did was took each word, ordered the characters by actual value. Okay. By sorting the characters and value is actual word. So the key is EHT, which is is smaller than H and H is smaller than T. So we ordered the characters of this word, and ACT is CAT, and similarly ACT is again for another word. Act remains as is because A is smaller than C is smaller than T. So we ordered the letters of the word in this manner, and once you are done with it, so your key becomes the ordered letter. Okay. So if there are two words with the same set of letters, the key is going to be same for all those words. Let me, ICT should be CIT. Yeah, you are right. You are right. Thank you for pointing that out. So it should be CIT. Okay. And that means my this plan goes a bit haywire here and it becomes CIT. And similarly here it becomes CIT. Okay. So first your line get broken by words. Then for each word, what you do is sort the word by characters. That becomes your key, and value is actual word. Value is just actual word, and that's your okay. Now this is given out by your mapper. When it goes to Hadoop, what Hadoop does is orders it, orders it by the key. So all acts come together and the value is actual word. This is your, you know, the one you created after sorting the characters or after ordering their characters. So if there are two words, if there are two words which are anagrams, they will have the same set of letters. And if they have same set of letters and those letters are sorted, then it will be the same word. So, and then it will be grouped together. Act got grouped together, their values became together, ACT, cat, tag. Similarly, for rest of the things it is not that case. Now here, after that, reducer, all it did was just printed the value. That's it. Now problem with the reducer is reducer cannot truncate the output per se because it will be executed per line. So it cannot never really give this output. It will also give CIT, TIC also. So in that case, you might require to truncate the output by yourself. Okay. Okay. So yeah. So if is it clear to you? I would like to go through it again if it's not clear to you. I'd like to describe it in detail. Okay. Suksa, great, great. Last thing I said was reducer will never be able to this code is wrong. This program is wrong because reducer will never be able to truncate the output. Okay. At most it can do is null, null, null. So here all it will print is blank, blank, blanks. Okay. At most that's all it can do. Okay. Because it has no, I mean, it has no control. It is reducer is executed on each line. Okay. At most it can return null. Okay, let me Shashank, let me repeat. So our objective here is to the find out who are anagrams of each other. Okay, anagram means that it's it's a rearrangement of the letters. Okay, and in an arrangement of letters, which is a word, if you sort them, order them together, order the letters, then no matter what arrangement was it, after sorting, it will form the same arrangement. So two anagrams of each other, if their letters are ordered, they will form the same word. So cat, act, and tack, if their letters are sorted, they will form ACT. Okay, all of them. And we are utilizing that property of anagrams. So we made that as a key. We took a word, ordered the letters by their in, ordered the letters of it, and made that as a key, and the actual word we have preserved and kept it in the value. Okay, and hence we got this key and value set. After that, Hadoop will automatically order it and group things by key. And key is what? The the letter which was the word which was generated after sorting the letters. Okay. For CAT it's ACT. For ACT again it's ACT because we have ordered the characters of a word. Okay. Because A comes before C in alphabets and C comes before T and so on. So Hadoop will do this magic. This magic from here, from this to this. This whole magic is done by Hadoop for us. Okay. So from here, from here to here is done by Hadoop for us. And then in the next step, Hadoop will do the reshuffling, and for each key which is same, it will group the values together. Okay, and that is will be available, and each key value will be handed over to your reducer, which reducer will do whatever it wants to do with it. And there you are. I think we can use key I think we can use key equals sum of ASCII values on the letters also to make it more efficient. Not really, not really, because AB, if you sum both of them, will be equal to AC will be equal to BC. Let me just think. AD will be equal to BC. So you cannot sum the ASCII value. Okay. So guys, did you get it? So Sasank, was I able to explain? The reducer has to return something. Reducer can return null. Okay, can return blank, but still, I mean, reducer cannot, truncate the output. It will be up to you. Okay, you remember in the MongoDB and elsewhere, what you do is you have key and value, and it keeps on printing key. Okay, great. So, do you want to take a break if you are tired for 10 minutes? Let's take a 10 minutes break. Hi, Kalyan. Welcome back. So, I think it's 10 minutes already. Okay, great. 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 I have everybody else's Gmail ID, so nothing to worry. Okay. Except for Sashank, except for Suksavat, I had everybody's Gmail ID. Yeah, I have made a Google Plus community for with my main page. In that, you are all added, and you can start communicating. Okay. I have invited Kalyan and Hari have already joined that community. Okay. If that is not comfortable, I can create a Google group as well. Okay. Okay. Now, should we start? So, this anagram problem is probably clear to everybody. If it is not clear, then let me know now. And what portion, then I can explain to you better. Okay. So I think it's clear to all. Great. If it's not, then just either you drop me an email personally, or you drop an email, message. Uh, I mean, on my phone. We can discuss separately also. No worries. Okay. These are important aspects, and these are actually what people ask in interviews when they are hiring for for any big data work. Like for example, I was hiring for my no, you haven't missed anything, Chintamani. So for example, I was hiring at InMobi for my big data architect, and basically, uh, I mean, hardly 1% of the people, or hardly out of 10, only one guy could actually solve this anagram problem, although he had been apparently working on big data for some time. Okay. And people ask these kind of questions. I had been hiring for some time. If somebody knows about, you know, Hadoop and all, the first question they ask is that how do you do this or that using MapReduce? Okay. So it is actually important to know conceptually at least, even if you can write a pseudocode, even if you can write the steps of converting any doing any job using Hadoop or using MapReduce, it is good enough. Even if the code it's not a code, it doesn't have any syntax. Even if you write just steps, do this, do that, and then that's it. This is going to be my key. This is going to be the values, and this is what my reducer is going to do, and this is what my mapper is going to do. So if you do that, that is sufficient. And if there is a proper is a good company which is hiring the people to work on Hadoop and solving larger problems, or a data scientist kind of a job, then they will ask you at least one map reduce problem. Okay, they'll ask you at least one map reduce problem, definitely. Okay, because rest of the things you can, mug up, but this is not something you can mug up. This is something you can only understand. Okay, that is why I have kept this whole exercise as only the problem solving exercise. Okay, now I'm moving to the third problem, and as we are moving ahead, the problems are getting difficult. Now the third problem was that a file contains the DNA sequence of people. You person name, or you can imagine that it's email ID of a person and their DNA sequence. A DNA sequence is basically a sequence of these characters. Now we have to find all those people whose DNA is either identical or is a complete mirror image, right? In this example set, okay, so in this example set, we have to find all the people who have identical DNA. So first column is the name of the person or email ID, identifier of the person, email ID or anything, whatever you want to imagine. So first is person ID, second column contains the DNA sequence of each individual. Your objective is to find all the people who either have identical DNA or have exact mirror image. So anybody who is having the mirror image or having the exact DNA are considered the same people from the same family. Okay. Well, that's not true. It is just for the sake of problem I have formed it. Okay. Our objective is to find all such people who who either have same DNA or completely mirror image of it. So how do you solve this kind of problem? So in this example, user 1, user 2 and user 4. User 1 and user 4 have identical DNA, while user 2 is a mirror image of user 1 and user 4. Okay, this is not an anagram because AGCT is not accepted. Okay, if there is a user 6, okay, if there is a user 6, let's just imagine user 6. Okay, and user 6 is AGCT. Okay, so user 6 is not part of this family, it's separate. Okay, so it cannot be exactly like anagram, right? So you understood my problem. Should I explain again what the objective of the problem? So any two persons are considered uh, uh, from the same family if they have either exact same DNA or a mirror image of the DNA of another person in that family. So you have to, after looking at all these DNAs, you have to do the find who all belong to same family. You have to bunch up. You have to group these people together. How do you do it? Anybody? I'll give like 5-10 minutes to solve everybody. After discussing with the people in the class, lots of people were of the opinion that we should be giving more time to solve the problem there. It should become a bit of a tutorial exercise in which I can assist while you solve the problems. After every theory class, some people were of the opinion that we should keep a tutorial kind of class. Okay. So that is why I've kept this whole marathon session on problem solving alone, because uh, I mean, probably, I mean, not only me, but I have seen other data sciences classes and other really good Hadoop classes. They keep a whole session on just problem solving on Hadoop. Okay. Sort by DNA code and group. Yes. How do you form the DNA code? How do you say, let's say we make a column. Let's say what you're suggesting is, let's form, okay, let me first make a separate table. Okay, okay, don't worry, don't panic. This. This is what output we are expecting, right? I'm just going to decrease it a bit. So from this comes. So what Suksavat is suggesting, that sort by DNA code group. Okay. So probably what he mean to do is this. Okay. Okay. Here, if you basically what you are suggesting is to do sorting, basically switching this. Okay. So all I have done is, okay, this is what you're suggesting. Okay, let me see what is the approach. N to Lx. Take the DNA sequence, compare with other DNA in reverse string, count if it's same. Okay, okay, okay. This is interesting approach. So you take a DNA sequence, good, then compare with other DNAs in the reverse string, and then count if it's same. Yeah. So the step number 2, where you are saying asking me to compare DNA in reverse string, which means you want me to convert it to the reverse and then look up everywhere. And how am I going to do that lookup? Okay. So for each DNA, I'm going to find again in the DNA. Okay. Which means any square kind of complexity are we talking here? Or at least n log n. Okay, let me make it simple. So we go from top to bottom, we pick up a DNA, we try to find out the DNA in the whole list. If it is found, then it is good. If it is not found, then we make a mirror image of it and then try to find. Okay. So that's one approach, but that will be very inefficient. And since the data is huge, this will take a huge time. Can we convert that into a sorting problem from a lookup problem? Because you are suggesting to do a lookup. Okay. Now let me take. Okay. Gaurav is saying that in map create sorted pair of DNA and its mirror image. Perfect. Perfect. And emit. Okay. Good. Good. Okay. And then username. Good. Okay. In reduce, Hadoop will combine an all sorted pair. Perfect. make a pair this DNA and sort the pair, make that is the key, and then remaining same reduce them. Okay, okay, okay. Do we see any other approaches here? There are lots of approaches possible actually. Okay, I'm waiting for other approaches actually. I'm waiting for other. So, have you understood the problem? Check in the sequence of alphabet letter from start and end. Okay. No, I did not get this one. I did not get this one. Give me an example, Hari. So Hari is saying that same thing you are saying, right? Like anagram, right? Similarly, it will be for T A G C T also, right? For AGCT also, it will be the same thing. Basically, given a list of DNAs of people, we have to group these people together. hmm hmm No, but how would you compare? How would you compare, and with who will you compare? In map, what are you going to do? How will your map look like? What will be the role of your map? And and then what will be the role of your radius? No, I'm not saying that these are palindromes. Okay, these are not palindromes. In case if that is what you're saying. Okay, take your time. Take your time. You have easily two more minutes. Take your time. So, what will a map give the output for this set of values? Okay. So basically what we are trying to do is for user 1 AGCT, okay, and you can shift enter to, or you can write somewhere and then put it into one go. User 1 AGCT, you have sorted the letters, and then okay, Sank is saying we can sort like AGCT user 1, good, and then user 4 AGCT, okay, and 2, okay, city, okay, okay, so okay, explain a bit more, I want to understand. So Hari is saying AGCT will be for user 1, okay, good, AGCT for user 2, okay. Right, right. So you are saying the same thing. After reversing, basically what you are saying is out of the minimum of the mirror image and itself, and that you are even without you are saving one more step, even without reversing you are doing it. Okay. Even without reversing you are doing that, right? So you first check i- if your first letter is less than last letter. If it is lesser, then you don't do the translation. In case it is if it is lesser, then you don't do the translation. If it is more than first letter is bigger than last letter, then you do the translation, then you reverse, right? I got it now. Got it. So you saved half of the step. Instead of always reversing, you saved a bit of time. Okay, that's nice. That's a further optimization. Okay, Chintamani, let me clarify it again. As per him, for me, the problem statement is not clear. I thought user 6 should be part of user 1, user 2, and user 4. No, 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 no. So if you see, user 6 is having the same uh, DNA, but is neither mirror image or identical to user 1 or user 2 or user 4, right? It's because G and C are not in that order. You got my point? Yeah. So basically, either the mirror image of the DNA or identical DNA is considered as the same family people. I mean, this is just a problem statement. It's not in reality. But for the case of our problem, two strings which are reverse of each other or are identical belong to the same family. Okay, okay, good. So we have to find such family. We have to do help these people find their families. And these are billions people. These are billions in number. Okay, okay. You want more time? Yeah. So the key to any map reduce problem is to come up with the unique key. And then how do you reduce? Exactly. How do you summarize? It's like group by clause. How do you group on what column to get the result? And if it is not there, the column is not there, how do you form that column? Okay, carry on. Right, right. So the more you try to solve these problems, the more idea clarity you will get. Okay. So other than what is happening right now is other than thinking in terms of map reduce, all I'm trying to make you think in terms of how do you solve problem by doing sorting rather than doing lookup. Okay, doing search. Okay, yeah. Key is in the same DNA or the mirror. Yeah. Kalyan, anybody? I'm waiting for your solutions. Basically, the idea and objective is to bring these people together by finding the key. Okay. So in case we are just putting the DNA sequence as the key, then only the people who belong to identical DNA will be reduce will be able to group them together. By sorting, they will come together. Okay. Now, since we are also looking for mirror images, so if there are two persons who are mirror images of each other, so if you reverse one person's DNA, it'll form the other person's DNA. And out of all the mirror images, out of the two mirror images, if you order them by uh, their order them by their ASCII value, then you should be able to figure it out. Okay, so that is why, say, uh, i- i- if you have two words, right, some two strings, okay, and they are mirror images of each other. If you sort them, the smaller one will the come first, and if that is the key, then all such DNA, all such people will come together to. Okay, all these all, the keys for all such people will be the same. Okay, okay. So let me show you what I'm trying to do here. Here, it's little bigger. I've just for the demonstration purposes. This is what I'm trying to do. I'll hide it. Yeah, just a second. Good. Now, if you look at it, this was our data. What Mapper did was M- Mapper formed a key ACGT. Okay. Now, what it did was it took this key, did a mirror image. Mirror image of this will be. Uh, Let me just see. So mirror image of basically it will do a minimum of ACGT and TGCA. Okay. So it reversed the DNA and found the minimum out of it. Okay. So that the people with the same DNA will have the same key. Okay. Even with people with the mirror image of the DNA will always have the same key. So this and this, out of this we found this as a key. Okay. And yeah. Similarly, for this guy, we did a mirror image and then it becomes ACGT again. Okay, ACGT. So mirror image of this is going to be ACGT, which is smaller than this one. So we kept this one here. Similarly, for this guy, we did a mirror image and found out that when comparing with the mirror image and this string, this one is smaller. So we kept that the smaller number as the key. Okay. So meaning that all the mirror images of a word of a DNA will have the same key. Okay. Mirror images as well as the other ID will have the same kind of key all across. And this is the key. This is the key. Similarly, ACG and ACGT and ACG, because in this case, and if you, I'll just add one more point just for the demonstration. So if you have ACDA, okay, now you do a reverse for this ADCA and compare ACDA and these two guys, the actual DNA and the mirror image of it. Which one is smaller out of this? If you have to put them in ascending order, which one is smaller? This or this? This, right? Because it has got C and it has got D. So now this one will be the key for this. Okay. So basically the selection of the key here is the most important criteria. Right. So see, min or sorting is exactly the same thing, right? Min is basically comparing two values, and sorting is also at the end of day comparing two values, right? So basically, the objective is that people with the same DNA should come together, as well as those having mirror image. Okay, those having mirror image, if you find out, if you take the mirror image, if you take a string and do its mirror image and keep that identity, but it is going to be, I mean, find out which one is smaller out of it and make this that as the key. Okay. So every mirror image and a DNA is going to have the same key. Okay. Can somebody describe it better than me? Why did we select this mechanism of finding the comparing these two and then? So overall objective is to feed the Hadoop with the keys, okay, which Hadoop will try to group it for you. Okay. 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 Any other ideas? So we defined a key which is smaller of DNA and its reverse. Whatever is smaller, we make that as a key, because that will ensure that all the people who are mirror image of me will have the same key as me. Okay. And hence this becomes a key, and rest of the job is well done by Hadoop themselves. It grouped user 3 and user 5 together, and it grouped user 1, 2 and 4 together. Okay. This is how it happens. And then these two steps are done by Hadoop for you. Mapper converted this into this. Key here it did a DNA as the first key, smaller of DNA or its reverse, and the user becomes the person. User becomes the value, and when Hadoop runs on it, it first sorts them by their key, which is the selection which we made earlier, and then values, and then groups the values together for a key and gives out the output. Reducer does nothing effectively. Reducer just puts the comma between these array of values. Okay. So am I going off track somewhere? I mean, quickly, if I get a, yeah, AGCT to user 6. Oh, I have actually removed ACGT user 6. Wait, AGCT. Okay. Should I put it again? Let's say that we have a user 6 AGCT. Now problem is that AGCT is not a mirror image of this guy or this guy, so it should not group with them. Okay. Now out of AGCT, what is the reverse of AGCT? AGCT's reverse is TCGA. Okay. AGCT and TGC. What is minimum out of these? Which one is smaller than out of these two? If you have to sort them, which one will come out as smaller out of AGCT and TGCA, TCGA? AGCT, right? So AGCT becomes our key. AGCT becomes our key, and here we'll add it. I'm just adding one more value for demonstration purposes, and we'll say user 6. We'll say user 6. Okay. So for a user 6, we have got AGCT and the mirror image of it, which is TGCA. The minimum of it will always be AGCT. Okay. Similarly, these two, minimum of these two will also be the same always. Okay. So this will ensure that all the people who are my mirror image or who are identical to me will always have the same ID. Similarly, if I have a, okay, so this way, okay, so whether my ID is this or this, I will always get a newer key. Whether my DNA is this or this, I will always get a this key, AGCT. Okay, and that is why this is the key. Got my point? So for every DNA, what we do is we reverse it and then compare which one is smaller out of the two, make that as the key, so that because everybody who is having the same DNA will end up with the same key, and hence, okay. Should I take one more example like this? Now, now imagine, now we got a user 7 here. Now we got a user 7 who has got TCGA, okay, TCGA, right? Now to find out what should be its key, what we have done is minimum of TCGA and the what is the opposite of TCGA? AGCT. Okay. The minimum of these two will again be AGCT, right? Effectively, both these guys, user 6 or user 7, will end up with the same key. They will both end up with the same key, AGCT and user 7 here. User 7, and when the data goes here, it will arrange them together, AGCT and user 6, AGCT user 7. Okay, and then user 7 and user 6 will come together, user 6, user 7. Okay, and hence your result will change to user 6 comma user 7. So user 6 and user 7 belong to the same family because they are the mirror image of each other. And this whole logic is actually extremely simple if we just have to look up, right? Now the problem with lookup is that say we pick up the first user, okay, we first find we first find in this whole list whether it is the same person who exists or not, okay. And if he is not existing, then what we do is we do a reverse of it and then search in it. So it will take a lot of time if we keep on doing it, if there are user base is huge, okay. That is why we came up with an idea that we generate these keys together, then we will sort it, Hadoop will sort it for you, and then it will bring all the people together but just by the way of sorting. Okay. Arun, Sasank, Chintamani, Kalyan, and Suksavat, Gaurav, Anto, Bhagwat, Hari. Any more doubts in this? Okay, okay. Great, 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 great. Okay, great. I'm not sure I understand how this work on Hadoop. Meaning, so I mean, all Hadoop has to do, right? Yeah. See, right now, I mean, the practical basically would be, I mean, I have given a simple demonstration of this thing. Okay. On this example, right now, I'll have to write the code for you. What I was planning is that I'll let you write the whole approach in your own way and then submit it. Okay. What will be the reduce and mapper? I didn't get it. Okay. Okay. So from here to here transition, these two steps where you see these dabbas, these two steps are done by Hadoop for you. From here till here, this whole steps are being done by Hadoop for you. Okay. And your mapper's duty is to translate this into this. And your reducer's job is to translate this into this. Okay. Great. Now I want to move on. Okay. Anybody else is having a question? Okay, let me. So Andrew is asking, in general, key as unique. However, here user is unique. Will that make any problem? In general, key as unique. However, here user is unique, right? So, yeah. Actually, I did not get the question. So, I mean, you try to create a key which when all the values of it come together, even if it's not unique, then Hadoop will ensure that it gets unique by clubbing all the values together. Okay. And could you rephrase the question, please? Or you take a bit of time. I would like to understand the question. So these are the interesting aspect of problem solving using a tool like Hadoop, which provides you a certain things already. And okay, that is why the file columns were reversed. Yeah, right, right, right. Okay. So great, great. So I'm moving on. And to please, confirm me if you got the answer to your question. Otherwise, if you can rephrase it for me, if you can rephrase, then I can answer. Actually, I'm not able to understand the question. Okay, okay. Never mind. We can discuss it over the phone or you can write me directly. No issues. Okay. Now, this is a very difficult problem. Okay. And for those who don't know a history about MapReduce, okay, MapReduce was invented by Google and they did it for PageRank. And PageRank is what this map voting looks like. It's a very simpler version of the voting. Okay. In this particular kind of voting, what people have done is that they have checked their everybody's bank account and said this is the worth of each of the individual. And when they are voting for somebody, it is based on the people who are people's worth, the voting is being considered upon. Okay. In case of Google's PageRank, when a web page is linking to another web page, it is effectively voting to the other page. And while voting, before the voting, each page has got a rank. Okay, it has got a value, and that value converts into the number of votes to the page being referenced by a page. Okay, so in the similar manner, I have tried to make the problem very, very simple as compared to what it looks like. So we have got two lists. First is who voted for who. A voted for C, B voted for C voted for F, and so on. And then we have second list where we have listed the worth of A, the bank account of A had 5 lakh rupees, while B has 1 lakh, C has 11 lakh. And when you combine these lists together, I mean when you say so the C was voted by A and B, right? So C's value becomes 6, 5 plus 1. And F was voted by only C. So the F's value becomes 11 because C is far more valuable than A and B. And A and B did not get anybody's vote, so their total vote count is 0. So given this kind of huge lists, you have to find out what is the vote count of each individual after the voting is finished. So if you are given a list of who voted for who and who has got how much worth. This is a little difficult, a little difficult. You take 10 minutes of your time and try to solve it. Okay? You take 10 minutes of your time, try to solve it. Okay? And in the meantime, keep asking me doubts about the problem statement. Right? So Bhagwat is suggesting that, yeah. So the problem is that it could have been easier than when let's just imagine for a second that list 2 is small. Okay, list 2 is small. Now what we do is We load list 2 into the memory. Okay. Make a big dictionary A and the worth of A. Worth of A is say, you know, the value in the dictionary and something like that. Now, when we are iterating over list 1, we just keep on doing pretty simple thing. We keep on printing C against the value of A, C against the value of B, and then F against the value of C. And after the next step, when the summation will happen, you'll get the value. Okay. So, but lookup itself, this solve the problem because the map and reducer will sort it and then give the output. Let's say in mapper, we were looking into a very small set. Say list 2 is very, very small, or list 1 is small, whatever you can think of. Okay. So it would have been simpler. All we had to do was print each value every time somebody got voted by somebody. We just print its person's name and its value. And when the Hadoop will sort it for you, and that person's all the values given by based on all the votes, they will be aggregated together. So Bhagavad is saying, make a key by the votee. Okay, make a key by votee. Replace voter with corresponding worth. Okay, make a key by the votee. Okay, C becomes votee. Replace the voter with the corresponding worth. Okay. No, but how do you replace the voter with the corresponding worth? Are you saying you look it up in the list 2? How do you do that? Divide key and values into list 1. Okay, key 1, key and value. Perfect. In list 1, key and value. So CA, perfect. CB, then FC, and then, okay, so we brought the votee to the left and voter to the right, right? Great. B. Calculate worth, sum of the identical key by using L1 reference in L2. Okay. Okay. So what we have done, divide key and values in list 1, key value. Okay. Okay. So what we have done, Anto, is that we have swapped C and A, C and B, F and C. Perfect. Then calculate worth, sum of identical keys. Okay, so here the worth of C will be A plus B, and worth of F will be only C by using list 1 reference in list 2. Okay, okay. And after you union list 1 and list 2 to find out the vote count at 0. Okay, okay. Good, good. So I mean you are almost close, almost close, almost close. Yeah, almost there. Because that union part is little bit of interesting phenomena. So if is the problem statement clear to all, or I would like to make the if it's not clear, I would like to rephrase it. It's an unusual democracy where not everybody is equal. In our democracy, everybody gets equal voting right. Everybody's vote is one. Here it's based on how much bank account, I mean, how much money people have in the bank account. Take your time, Bhagwat. And you know, you can write somewhere else and then you can post it. No issues. Because your solution is going to get intermingled with others. Okay. Then, Gaurav. Now, sum of the worth of AB is simpler to say, right? That's what Anto was also saying. So, but the problem here is that when you say worth of A and B, you will have to look up in the second table, right? You will have to look up in the second table, right? And how are you going to look up? Are you going to load everything into memory, or you are going to make a network call, or are you going to make a disk call? How are you going to do that? That is going to be extremely costly, and that you are doing for each and every value, right? So let me look at Bhagwat's situation. If you make a hash table for lookup, again, a hash table takes a memory of around 4 times of the total data and is will remain in the memory in the RAM. So if you have got 1 GB RAM, you can't do it because there are more than 10 million people around the world. Okay. In reduce, we make additions 5 plus 1. Yes, yes. For C, yes. Now, the problem is if you can do that only if your VOTI is the key. Okay, VOTI is the key, which means that for C, A plus B will become that. Okay. Now, if you could some way convert this into something like A colon 5, okay, and then B colon 1, okay, and then when you are reversing, then you can sum up very quickly. Okay. Okay, so Bhagavat is saying take the list 1 and list 2, reduce the list so that we have A, okay, A, okay, so you merged these two lists into a single file. Okay, you can concatenated these two into single file, and then that's what map did. Okay, and after that you sorted based on A. So when you merge it, yeah, okay, and then what did you do? Okay, then create a new list with only values where C is the key and 5 is the value. Okay, okay. And if there are multiple values, what do you do? If say there are A is to voting to B also. Okay, so your list will become A colon B comma C comma 5. No, in this case, no. Let's say I just put one more here. I say A is voting for B also. So A colon becomes B comma C comma 5. No, you are almost there. You are almost there. Okay. Just think of it. Think of it. You're almost there. Okay. So Sashank is saying that in reduce we can make addition 5 plus 1. Yes. This is, yeah. Hmm. Yes. Is the problem statement clear, or should I make it again? Should I describe again? Chintamani, Antu, Arun, Gaurav, Hari, Shashank, Suksavat. Is the problem statement clear to you? Okay. 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 So problem statement is clear. It is just how do we solve it? It is a difficult problem, to be very, very honest with you. It's a difficult problem. So take your comfortable time, okay, and try to solve it by yourself. And just think of these two lists as huge list, very huge list. First, when you try to solve all the problems, we have a tendency to solve it by looking up. But when you think of these lists as huge list, as in 10 million people, then how do you get it solved? Through Hadoop. And remember that Hadoop can do a lot of efficient sorting for you. Had it been my database, all I would do is join these list 1 and list 2, okay, and then out of select votee from list 1, comma the worth of person from the list, and from table from list 1 comma list 2, where voter equals to voter of A equals voter of B, and that is how I would do it in SQL. No, I mean, Hadoop is not really a database, it's just an umbrella term. Okay. So, but if you think in terms of those, okay, it will happen that way. So the way to join two sets together is you can put them the way you can look up one value in another list is you can keep the key which you are looking for. So say you are looking for A in the list B. Okay. So what you do is you merge these things together, and when you sort it, A A will come. I mean, in the both the places, the values will be C and 5 will come together. Okay, C and 5 will come together, and in case of second row, the B space C and B space 1 will come together. Then C space F and C space 11 will come together, and when you group them, then you get the value of A, and you get the value of B, and you get the value of C. Yeah. So are you giving up? So Gaurav is saying I'm thinking. Okay, you give it a try. So instead of looking up a value from list A to list B, we can actually merge these two lists together on the same key for which we are looking for. And then those two values will come together. You have got two lists. One is who voted for who, and second is who has got how much worth. Based on this, all we need to do is sum up the values of C. So everybody is clear about it. Had it been, uh, you know, if we replace A with its worth in this table list 1 and put the voter in the second column and then we pass it to Hadoop, then it's pretty straightforward. Okay. Concatenate list A and list 2. Okay. We told Hadoop to read from both the files together. Okay. So it will internally concatenate it. Or you write two separate map job who does not have any reducer. They will concatenate it together. Reduce this list and we will have A colon 5 comma B comma C. Okay. A colon A A voted for B and C and A's value is 5. Good, good. So when they merge together, so for key A there will be C and for key A there will be a value called B and for key A there will be a value called Y. And when they get together it will become 5 comma B. Okay, then we sort the values and create a new list with B and C as the key. Okay, so it will get converted into B space 5 and C space 5. Okay, and then okay, okay. So anybody, do you think his answer is okay? What Bhagwat is trying to explain? Do you think it makes sense? Okay. Anto, Arun, Bhagwat, Chintamani, Gaurav, Hari, Shashank, Suksavat. Should we move or should I wait? Are you trying? I've got an answer from Bhagwat. Gaurav says he's trying. Okay. Take some more time. Okay. Okay. Sukhsavat says that yeah, it does make sense. Good. Okay. To me also it does seems to make sense to me. And let's see what others say. Okay. Okay. So Chintamani is saying that we can replace the value of ABC in the list A and add all vote E. Whenever a new vote comes up, adding. Yeah. Yeah. So that's what is the objective. Okay. That's what is the objective. Okay. We can replace the values of A, B, and C in list 1, adding all votes. Yes. Okay. Yes. Right. Then we have Gaurav's way. We need two map reduce, combine two list. Okay. AC, BC, and A5, AB. Good. And then reduce will be become A C5B, and then it for another reduce will become BC1 etc. And second map will be okay. Then second what you're trying to do is C A comma 5. Yeah. But why can't you just say C5A5 or C5B5? Why do you need A there inside that map? Why do you need C comma A bracket 5? Okay. 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 Hari, you there? Okay. Okay. To me, that seems quite right. Hari, what do you say? Do you think these solutions are correct, or you have your solution? Guys, should I move? Okay. Okay. So, see, today's session was basically these problem solving, and at least opening you up to these challenges. Okay. Now, this is the whole graph. Okay. This is the whole graph which I am going to keep looking at. Okay. Good. So this is how we solve it. So this is the fourth problem, right? So Gaurav and this guy, Gaurav and Bhagwat were able to solve it, and others also were able to approach it very decently. Okay, Chintamani and other people in the team. So let's have a look at it again. So we have got list 1 and list 2. So first step we did was we merged them together. Okay, these two files. And the way we merged is A, C, the way exactly it is, we just appended the two files together. That's it. Okay. Now when the sorting happens, so all these three values will come together. All these three values will come together and will form A as the key. What is the value for A? What are the values for A? You have got C, you have got B, and then you have got 5. Okay. So this is what you will get in the values. Similarly, for B, what are the values for B? You've got C and you have got 1. This is the job of Hadoop. Hadoop will convert this unordered list into an ordered and will give you this output. Now you have got A voted for B comma C and A's value is 5. This is what it means, right? So B and C both got 5 5 value. Similarly, C got 1 value and F got 11 value. Okay, now if you sum up everywhere where all C got the value, then you will get the answer here. Okay, so B got 5 value, C got 5 value, again A got nothing, so we just print A also with it. Okay, A also, that A got nothing because A has voted, so A has got 0 value. Okay, and then this is just for the placeholder because in answer we needed 0. Okay, then C was voted by B whose value is 1, and then that is why C's value becomes 1 and B value is 0 still, and F is voted by C whose value was 11. So reducer all it did was for each of the values it received, it printed for 5BC, it converted into this B5 C5, then C1, then F1, and put 00 for the key. So you got a list of this, and then you wrote another set of map reducers, which basically mapper did not do anything. It just printed as is, and reducer all it did was summed up all the value for the keys. So for A, if you see, there is only one value which is 0. Okay. For B, there is one value called 5 and there is another value called 0. When the two summed up, it will become 5. Okay. For C, how many values are there? C5, C1 and C0. So total C has got votes as 6. F has got a vote of 11, and that's pretty much it. So we needed two set of mapper reducer. First mapper merged two files and the reducer converted started giving the value to each individual, and second set of map reducer basically summed up the total value. Does it make sense to you? Is there any doubt? I mean, can you help me understand? Okay, okay, good. So are you confident? Are you getting some confidence, Arun, Chintamani, and everybody in the team on the map reduce? So what I'm thinking that you should actually go through all these four problems again. Okay, you should go through all these four problems again. I'll be giving one more problem. Okay, and you should solve all these four problems and keep on mailing writing to me. Okay, make this diagram or make an approach. It doesn't need to be a code. In case you write in any of your language, it'll be good, it will be beautiful, but a steps or pseudo code is sufficient for me. So please go through all these problems, all four problems, and just write the approach to me. Just explain the approach. Okay. Explain the approach. The way I have shown in diagrams. Okay. That this is what I made the ID and this is what I made the key. And okay. Yeah. We are going to try Hadoop sometimes later. Okay. Because trying Hadoop will be far simpler. I can show you. Okay. And I want to take maybe a half hour of next class into there are few things left with respect to Hadoop practical. First, uh, I have only given you a live example of my MapReduce on streaming job, not the Java one. So I'll give a 10 minutes task on Java. Okay, I'll just demonstrate, oh, this is how you write in Java. But that's not required. That's not, the do or die situation. What is important is how do we convert our logic into MapReduce things. Because in case you are able to break your logic into MapReduce, anybody can do the coding work. Okay, anybody can. I mean, you yourself can do the coding part. Okay. And also, once you are clear about MapReduces, then you will also have clarity of thought in pig Latin. You will have a clarity why it is so. Why it is so. When you will be writing your pig language, then you will be saying when you're writing query in the pig, then you'll saying, oh, this is the reason. Okay, this is what it is doing under the hood. Oh, okay. Yeah. So here you can do basically the way I have written for A0, I can write for B5. Yeah. So result is written here like this, right? Basically, I have added one more row here just for example's sake. That is why there is a difference, Shashank. Okay. I've added one more example here. Here it was that this was not there in the main problem statement. Okay. Okay. So basically AC, BC, AB, CF, AC, BC, AB, CF. Right, right. Okay, what difference did I make? So here A0 is fine, C0 is no, C1 okay. Why is B? Yeah, B is wrong because actually this row I just added actually. Okay, this row I added but I did not update here. So B was voted by A. A's worth is 5. A0, B5, C6, F11. Thank you for pointing that out. Yeah. Okay. Great, great. Thank you, Shashank. Okay. Now, basically, the whole objective of this class was to take you through these set of problems. Okay, because it takes a lot of time to actually convert a logic, a difficult algorithm into or difficult approach into MapReduce. Okay, great. So rest of the things, I'll just go over one more. Exactly. The idea is to move to sorting from the lookup. Okay. So this is probably clear to all, this diagram, MapReduce diagram. Okay. Great, great, great. Now, now there are few limitations of MapReduce. One is if job can be done on the single machine, do it on the single machine in a reasonable time. Mm, Unless and until you hit a bottleneck and you realize that it is slow, don't use MapReduce just for the heck of it. Also, in no sense it does not make any sense to run Hadoop on a single machine other than for testing. Second, the computation if the computation depends on previously computed values, then it is impossible. Now think about Fibonacci series. You cannot write a map reduce job for Fibonacci series. So there are some use cases, and there are actually many use cases. You will keep on getting stuck and say, okay, this is the class of problem which is not supposed to be addressed by MapReduce. Then similarly, full text indexing is not a great idea using Hadoop, because in case of indexing, you have to insert a value also. It's not a single time job, because what MapReduce will do is full reindex everything, as pointed out by Bhagwat, that oh, the result is not saved anywhere, the index is not saved anywhere. So that's exactly the limitation of map and reduce. Okay, you should not be using it for preparing indexes or preparing search results or something like that. It is for strictly for batch processing. Now what if your algorithm depends on a shared global state? Okay, then it doesn't help at all, although it lets you uh, you know do it. But since there is a global shared state, so each of the map call and each of the reduce call is going to make the call to the central place, and that's where the whole thing will become a bottleneck, because of the global state. Global state will become the bottleneck, will become the limited resource. So these are the few use cases where you should not be using it. Now there is one problem I would like to discuss. Okay, testing I think we can discuss after I have shown you the code. This is how you write Java 1. We'll again come back to it. Right now I want to give you a couple of assignment to discuss in the next class. Okay. We can use a cache, Shashank, sorry, Gaurav. But problem with the global cache is that for each record it is going to be looked up. It is possible, but it is going to be extremely slow. It doesn't help in any way. I mean, with respect to the speed. Now, first is code in your any favorite language, and pseudocode is pretty good for me. Okay, I do not have a problem. So whatever problems I have given you, all these four, please write your steps. Okay, if you are not able to understand it, just give me a call or look at the diagrams or listen to the video again, and then we come back to it again. Okay, so but make sure that you finish these assignments. Okay, because these assignments are going to matter when we will be awarding you the certificate. Second problem is similar to earlier one. Okay, basically you have got a whole text from Wikipedia, and you have to give the next word suggestion based on what the user has typed just now. Okay, so basically you have to prepare a long list uh, of recommendations. So like after happy people, sure, I'll post this PPT once the session is over. So after happy people have to you give the recommendation like birthday, new year, marriage. Okay, this is a common thing. So you are given a full, I'll be uploading the whole Wikipedia text somewhere, and then but you start planning your code. So you have got huge text what people are generally talk about, and here we are going to consider the Wikipedia, and then for each word you suggest the next five words. What is it that people type generally after this word, based on the past history? Okay, so you look at this problem and then you come up with your solutions, okay, in terms of MapReduce. So at the end of map, the objective is to reach this level. Okay, we have a big text file, let's say tab separated, okay, and we have this way, okay. This is the end result of each word. What are the 5 most common things people say, okay, all right. So this is the problem for the next session. Please work on both the things. First, write in pseudocode the all the 4 problem solutions to all the 4 problems we discussed today. To okay, and second is solve this problem. Okay, at least give the clean approach. This is what my mapper will do. These many mapper and reducers will be there, and this is what is going to be my logic in the reducers. Okay, please work on this. We have got uh, 6 days from today, so if every day if you spent 1 hour on it, it will be sufficient. Okay, so this is it from my side. The hands-on with respect to Java, I will take care of the next time. Okay, do not worry about that part. So this is pretty much. If you have any doubts, feel free to drop me an email or give me a call. I do not mind a call. Okay. If no, my assumption is that whether you are from analytics, whether from you are from any background, please write the approach, just the steps. Don't write the code, just write the steps. Okay. What will be your key? How will be? That's all. Only the steps. Okay. In case you are not hands-on with the coding, it's okay to write only the steps. So I have no suggestions for the algorithm. All I'm suggesting is based on the frequency of the next word, you give the recommendation. That's it, guys. Great, 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 great. It is a wonderful class. I'm thoroughly enjoying it. And good night to you, Chintamani, and good night to you guys. Good night, Kalyan, and good night, Suksavat. Good night, Hari. Good night, Anto. Thank you, Sashank. Thank you. Good night. Bye bye. Have a great day. Good night.